Students, today we are going to study the Newton's first law of motion and Newton's second law of motion. Let us try to understand Newton's first law of motion with examples. See, every body continue to be in state of rest or of uniform motion in a straight line unless and until an external force is applied on it. If we will apply any other external force, then what happen? If the body is in rest, it will be moving. So every body continue to be in state of rest or of uniform motion in a straight line unless and until an external force is applied on it. So here we will discuss it is in simple words, the net external force on body when it is zero, then its acceleration is also zero. The acceleration can be non-zero if and only if the net external force on body is acting on it. If the net external force on body is acting, then the acceleration it can be non-zero. But if the net external force on body is zero, then its acceleration is zero. Now here we are taking a block. You will observe here we have to see the weight. Weight is nothing but we have taken it is force of gravity and normal reaction that we have considered the symbol for it is capital R, that is exerted by the table. If we will see its direction, they are in opposite direction. Here the block is at a rest and the normal reaction R, it must be equal and opposite to the weight W. So here if you will observe the figure carefully, here the block is at a rest and the normal reaction R and weight W, it is equal and opposite to each other. So Newton's first law of motion is nothing but every body continue to be in state of rest or in uniform motion in a straight line unless and until an external force is applied on it. Now let us try to understand more examples of it. Here we have taken a block. Here the block it is remains at a rest because here no any other external force is applied on this block. But if you will apply the external force, what happen? This block it is moving, it will become in uniform motion in a straight line. So when you will apply any other external force, what happen? Here the block changes its position. So the Newton's first law statement we have already studied, every body continue to be in state of rest or in a uniform motion in a straight line unless and until an external force is applied on it. Now let us try to understand the example of ball. See, the ball continue to be in uniform motion unless and until it is acted upon by the external force. Now let us try to understand the example of car. Here we have taken the car. Here the car continue to be in uniform motion in absence of external force. Here if you will not apply any other external force, the car continue to be in uniform motion. So this is the Newton's first law of motion. Now let us try to understand about the inertia. You already know about the inertia. Inertia is what? It is a natural tendency of body which resists a change in its state of rest or of uniform motion. Here we will see the inertia of a rest, inertia of a motion and inertia of direction. There are different parts of it. Here the mass it is measures the inertia of a body. Here we will consider about the heavier object and lighter object. If you will consider the heavier object, it is having more inertia than the lighter object. If you will take a 5 rupee coin and 1 rupees coin, the 5 rupees coin it is having more inertia as compared to 1 rupees coin. So here if you will take a stone of a size of a football has more inertia than the football. Here we have compared a stone and football. The stone is having more mass, so the stone having more inertia as compared to football. Same like that they have given here two balls. A cricket ball has a more inertia than the rubber ball of a same size. If we will take a cricket ball and rubber ball of a same size, here the cricket ball it is having a more inertia than the rubber ball. So the inertia here it is a natural tendency of object of a body which resists a change in its state of rest or in a uniform motion. Here we will see one more example of a inertia of a rest. For that we have taken a beaker, we have to take a cardboard. When we flick the cardboard. See, we have to take 5 rupees coin also. When we will flick the cardboard, observe here, the cardboard, it comes in a motion, but the coin, it remains at a rest. So the coin, it will be fall in a beaker. So this is the example of inertia of a rest. Means here inertia, it is a natural tendency of object. It resists the change in state of rest or in uniform motion. Now let us try to understand about the momentum. The momentum, it is nothing but product of mass and velocity. So obviously the momentum is a quantity of motion in a body and it depends on its mass and velocity. For momentum we are using the P letter. So P is equals to m into V, and the momentum of body is defined as the product of its mass and velocity. Here the momentum is equals to mass into velocity, that we can write P is equals to m into V. The momentum, if you will see this relation, the momentum is directly proportional to the mass. Here if the cricket ball and tennis ball move with the same velocity, the momentum of cricket ball is more. Why? Because its mass is larger than the tennis ball, as we have seen in inertia also. Here if we will take the cricket ball and tennis ball, both are having a same velocity, but if we will see the momentum of a cricket ball, it is more because its mass is larger than the tennis ball. Now let us try to understand about its velocity. If we will see this formula, P is equals to m into V, the momentum is directly proportional to velocity. Here if we are having a two cricket balls, they are moving with different velocity, then the momentum of the ball with a greater velocity, it possesses more momentum. So here we have to take the cricket ball, it is having a different velocities, but if you will see the momentum of the ball which is having a greater velocity, they possess the momentum, more momentum, because the relation is that the momentum is directly proportional to velocity. More is the velocity, more is the momentum. Now let us try to understand, if the body is at a rest, its velocity is 0, hence the momentum is obviously 0. According to the formula, P is equals to m into V. If the V is 0, then the momentum P is also 0. Here the every body, moving body, possess the momentum. Momentum is which quantity? Vector quantity, because it is having both magnitude as well as direction. If you will see the SI unit and CGS unit of momentum, the SI unit of momentum is kg meter per second. Kg is a unit of a mass and meter per second is a unit of a velocity. CGS unit of momentum is a gram centimeter per second. Gram is a unit of mass and the centimeter per second, it is a unit of velocity. So you have to know both units, SI and CGS. Now here we are discussing the Newton's second law of motion. Now only we have discussed about the momentum, so it's related to the momentum also. The rate of change of momentum of body is directly proportional to applied force, and it take place in the direction in which the force act. So here you can see the relation, F is directly proportional to change in momentum divided by time taken. Change in momentum divided by time taken, it is nothing but what? Rate of change of momentum. So you can say like that, the force is directly proportional to rate of change of momentum, but if you will see its direction, it take place in a direction in which the force acts. So see here we have to know the formula of momentum, as we have learned, that is P is equals to m into V. Here according to Newton's second law of motion, we can write this formula, F is directly proportional to change in momentum. For that we have considered delta P and the time it is delta T. So we can write F is equals to K into delta P divided by delta T, where K we have taken it is constant of proportionality. So see here we can write it is like that also, F is equals to K limit delta T tends to 0, delta P divided by delta T. So here F is equals to K into dP by dt. So these are all equations of momentum. So we can prove here F is equals to m into A. See already here F is equals to k into d dt of mv. As we have learned already about the p. P is what? Momentum. P is nothing but m into v. So instead of p, we have taken m into v. So k is a constant of proportionality. We can take m outside. Observe it. F is equals to k into m dv upon dt. Dv upon dt is nothing but what? Acceleration. Dv stands for change in velocity, dt stands for change in time, and therefore dv upon dt, it is nothing but acceleration. So we can write this equation. F is equals to k into m into a, and where k is a constant, that we can take here 1. So if we will take the value of k is a 1, we will get this equation. F is equals to m into a. This is also the Newton's second law of motion. This is the equation for Newton's second law of motion. The statement is that the rate of change of momentum of body is directly proportional to applied force, and it takes place in a direction in which the force act. So we will discuss about acceleration. As you know already the formula of force, F is equals to m into a. We can write the equation for a is equals to what? F upon m. So here the acceleration produced in body is directly proportional to the force and inversely proportional to the mass of the body. Observe the relation. A is equals to F upon m. A is directly proportional to F and A is inversely proportional to m. So if we will see about the force is which quantity? Vector quantity. Force can cause the acceleration or deacceleration also. So here the acceleration, if we will see, in case of car, the accelerator of car, it accelerates, and the brake, it what? Deaccelerate it. So you know about the accelerator and deaccelerator. So here we are discussing about the SI unit of force, that is a Newton, and 1 Newton, it is nothing but the force which when acting on the body of mass 1 kg produces an acceleration of 1 meter per second square in it. We already studied the formula. F is equals to m into a. If the value of force is a 1 Newton, at that time the mass is what? 1 kg and acceleration is what? 1 meter per second square. So with the help of this we can write the definition of 1 Newton. It is nothing but force which when acting on body of mass 1 kg produces an acceleration of 1 meter per second square in it. Here you have to know some important points about the second law. Here the first, you have to know about F is equals to 0. At that time the acceleration is also 0, because we have seen this is obviously consistent with the first law. You already know first law, Newton's first law of motion. Every body continue to be in state of rest or in a uniform motion in a straight line unless and until an external force is applied on it. If the value of force is a 0, then acceleration it will be also 0. The Newton's second law in a vector law. Here it's in vector law. It is the equivalent to the 3 equation, one for each component of the vectors. Means we have to discuss it is for x, y and z. So fx is equals to dpx upon dt. So you already know, now only we have proved f is equals to m into a. So we can write fx is equals to m into ax. Same like that we can write for a y, fy is equals to dpy upon dt, that is m into ay. Same like we can write for a z, fz is equals to m into az. So these are all equations related to the Newton's second law. So today we have discussed about the Newton's first law and Newton's second law. Next time we will discuss about the impulse and Newton's third law of motion. Thank you.